All right, welcome to lesson 2-1 called If-Then Statements and Converses. Today we're going to be talking about conditionals. And what a conditional is, it's a statement that's written in if-then form. So, for example, if we have the mathematical statement, if B is between A and C, then AB plus BC equals AC. That's an example of a conditional statement. And here's a diagram for that. So we know that we've got points A and C, and B is somewhere between them. It did not say it's a midpoint, so just keep that in mind. The word between does not mean in the middle. So this is your segment addition postulate, by the way, that you had learned previously. So A to B, the distance from A to B plus B to C will equal A to C. That's an example of how you write a statement as a conditional. Now we have some special notation for conditionals. We say if P, then Q, or we can use this arrow symbol, which is red, P implies Q. And there are parts to our conditionals. The part that is called the hypothesis is the part of the conditional that follows the word if, and it follows. It does not include the word if, so it's the P part. And the conclusion is the part of the conditional that follows the word then, so it's the Q part. So let's look at some examples. Not everything today will be mathematical. We're going to use some English sentences to help you kind of wrap your head around the concept of conditionals and converses, which is the theme for today. So if I give you the everyday statement, a pet that is a Boston Terrier is a dog. If we were to write that statement as a conditional, what we do is we write it in an if-then formation. So you'd say something like this. If a pet is a Boston Terrier, comma, then it is a dog. Now, if we wanted to identify the hypothesis part, remember, it's the part that follows the word if. So it follows everything after if. So it's the a pet is a Boston Terrier phrase. And then the conclusion is the part that follows. So again, follows the word then. It is a dog. Okay, let's get to our second page. So here, we'll be using deductive reasoning throughout our studies for the entire year, and actually every single time you are doing some mathematics, you are using deductive reasoning. And it's the process of drawing logical conclusions using an argument. So here, again, let's use our everyday sample question statement. Right here, we've got statement 1, a pet that is a Boston Terrier is a dog. And then we've got statement 2, which is telling us Kim's pet is a Boston Terrier. Therefore, think about what you would conclude deductively based off of statement 1 and 2. Hopefully you said something like, Kim's pet is a dog. All right, so now once we have some conditionals, we like to write the converse of the statement. And that's basically when you interchange the hypothesis and the conclusion of the conditional. So it's basically saying if Q, then P. And your notation, if you wanted some math symbols, it would be Q implies P with this arrow. So you don't say arrow P, you say Q implies P. So now a counterexample is an example that will actually prove your statement as false. Now, it only takes one counterexample to prove a statement false. And also, the counterexample is an example where the hypothesis is true, but the conclusion is false, which I know can be a little confusing. So let's kind of break it down. So we've got this math sentence. A polygon with 4 congruent sides is a square. So let's first write this as a conditional. I would like you to pause this video right now, and I'd like you to try parts A through D and see how it goes. And when you're ready to turn it back on, and we'll walk through it. Okay, so writing the statement as a conditional, you would say something like, if a polygon has four congruent sides, then it is a square. So that's first writing it as a conditional. Now what we'd like to do is decide if it's true or false. So you're wondering to yourself, if I have a polygon that has four congruent sides, is it always going to be a square? So this part you have to think about an object that has this going on, but does it have to be a square? That's how you figure out your counterexample. So I think to myself, think of something with four congruent sides that's not a square. And I finally come to the realization that actually a rhombus would actually do that. So I would basically say this is false. And a rhombus is the counterexample. Okay, because when you think about a rhombus, it's a polygon with four congruent sides, but it does not have to have four right angles. All right, now we're going to write the converse of this conditional. So we come back here, we take these two statements and we swap out the P and the Q. So we're going to write the converse of the original conditional. So you're going to say, if a polygon is a square. And the word polygon, this can stay because you don't want to say if it is a square, then it is a polygon. It's just better to put the word polygon with the concept of square. So if a polygon is a square, comma, then it has four congruent sides. And remember, try to abbreviate as much as possible. Now we want to think about if this converse is true or false. So I have to think about all polygons that are squares. So I have to think about all my squares. Will they always have four congruent sides? So if you are a polygon that's a square, will you always have four congruent sides? And that is going to be true.